Question number 1 of this exercise says that a park is in the shape of a quadrilateral ABCD which has got angle C to be equal to 90 degrees and the four side lengths are given as AB equals 9 meters, BC equals 12 meters, CD equals 5 meters and AD equals 8 meters. We have to find how much area does this park occupy. So let's first draw the required quadrilateral. The area of this quadrilateral can be found by dividing it into two triangles, and that can be done by joining the vertices B and D. So let's join them. So as we can see, there are two triangles formed, triangle ABD and triangle BCD. In triangle BCD, we observe that DC is perpendicular to BC. So DC can be taken as the height while BC is the respective base for this triangle. So the area of triangle BCD can be directly found by making use of the formula half into base into height. Let's substitute the values. So we get 1 by 2 times 12 meters times 5 meters. So that on calculation gives us that the area of triangle BCD equals 30 meters square. Now that we have found the area of triangle BCD, our next step is to find the area of triangle ABD. But for that we first need to find the length of BD, and that can be found by making use of the Pythagoras theorem, which is to be applied to the triangle BCD, which is right angled at C. So in application we write BD square equals BC square plus CD square. So let's substitute those values and we get 12 square plus 5 square. That comes as 144 plus 25. On addition, we get that as 169. As we know that 169 is the square of 13, we can write that BD equals 13 meters in length. Now that we have found out the length of BD, we can find the area of triangle ABD. But as we see that the height for this triangle is not given, we will have to make use of the Hurons formula. So let's write that first. So by Hurons formula, we can find the area A of any triangle by writing under root S times S minus A times S minus B times S minus C, where S is the semiperimeter for a triangle and ABC are the three side lengths. We will have to find the semiperimeter for triangle ABD, and that can be found by adding up the three side lengths and dividing it by 2. So let's add 9 meters plus 13 meters plus 8 meters and let's divide that by. So that we get that as 30 meters divided by 2. So we can say that the semiperimeter S for triangle ABD equals 15 meters. Now that we have found the value of the semiperimeter, we can substitute these values back into Hurons formula and can find the area of triangle ABD as under root 15 times 15 minus 9 times 15 minus 13 times 15 minus 8. That on further calculation gives us under root 15 times 6 times 2 times 7 meter square. That on further calculation comes as 6 root 35 meter square, which is approximately equal to 35.496 meter square. Now that we have found the areas of the two triangles, the area of the quadrilateral can be found by summing up these two areas. So let's do that. Area of quadrilateral A, B, C, D will be equal to the sum of the areas of triangle ABD plus area of triangle BCD. So that will be equal to, by substituting the values, 35.496 plus 30, which is equal to 65.496, which is approximately equal to 65.5 meter square. And that is the area of the park.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.